Welcome to ECE 470 Senior Design Project. I will be discussing today about acoustic distance sensors, how they work and what applications they're used on in automotive systems. So let's get started with how they work. Distance sensors work by sending out an acoustic pulse. This pulse is nothing more than a sound. It's nothing more than just a sound pulse that travels out and comes back. The unit itself actually has a diaphragm, and what it does is it just sends out a pulse, hits an object, and the sound comes back. The sound traveling out and coming back happens within milliseconds pretty much. Really short, very short amount of time that passes between by the time the sound goes out, the sound comes back. This time, like I said, is basically it's a 0.001 second delay. You know, it changes between 0.001 and 0.002 as you're very close to your objects. As the sound has to travel further, that time absolutely definitely goes up. But one of the things, acoustic sensors are mostly used for short distances, so you normally won't do probably more than 10 or 20 meters at the most. In the applications, using it as a parking assist or just a backup assist, making sure you don't bump into something. They're very accurate within short distances, so within like a centimeter or so. I'll actually be doing a demonstration on that in a little bit with a Arduino and a distance sensor. Be showing you that shortly. But let me get back to how this actually works. So this time that it takes the sound to go out and come back. A microprocessor, what it does is it actually looks at this pulse of time that it takes for it to go out and come back and does some calculations with that. One of the things that it does is it takes the time that it took to get out to the object that it hits and bounces back. It takes that time, it divides it by 2, since we basically only want to know this distance right here. So if we were to just take what the sensor measured as a pulse, then we would actually get this distance and then also a distance back, and we would get twice the amount of time. So we don't want that. We only want one time, so you take the entire pulse, you divide it by 2. Now you've got your actual time that it took the pulse to get out. So what do you do with that? Well, we know that the speed of sound is 768 miles per hour. You guys see that? Yes, you can. Good. So if we know this, and we know the time it took, all we have to do is multiply the time it took for that pulse to go out, to come back, divided by 2, times this, and now you've actually got something you can work with, actually to do something with. You can actually calculate an actual distance away from something. The most common automotive applications for acoustic sensors is going to be backup warning systems and parking assist systems. I actually have a demonstration I'd like to show you now where I have a mock-up of a distance sensor using an Arduino, and also it's an 8x8 LCD display is using as the user interface, so you can actually tell the distance that you are from something. So let me show you that. Okay, what we have here is a mock-up of an acoustic distance sensor, and also just an object that you wouldn't want to back into, say if this was used for a car. That is the display that you're actually seeing looking down at the red LEDs. What they will do is as you get closer to an object, the user interface will let you know that you're getting closer, closer, and we have sort of a set place where it's like, yeah, don't back up anymore. So we have something that visually lets you know how close you are. As you back up again, you can see that this resets itself and lets you know that you are far away. Thank you for your time and watching this.